My name's Elizabeth Stockdale. I'm a lecturer at Newcastle University in the School of Agriculture, Food and Development, where I'm involved with playing with soil. So I teach students about how to look after their mud and work with farmers to help them understand how soil management can improve yields and improve the ecosystem service delivery from soils. So I quite often get asked what farmers can do to maintain their soils in a healthy condition to support healthy crop growth, and that's absolutely about balancing the soil physics and chemistry and biology, getting that balance right. So that means attention to the chemistry, the pH, the nutrients, the right nutrients in the right place at the right time. So that's all about fertiliser management and allowing crops to grow well. In terms of physics in the soil, well, that's actually about water movement, making sure the water can drain away when it needs to, but also that the plants have available water when they need to. And that's about having the pore space, the structure of the soil right, and digging a hole and having a look and understanding the right time to make cultivations or to manage cultivations appropriately is really important. And then there's the biology, and we've tended to not pay that much attention to the biology in the past because it's happened by default. If we get the physics and the chemistry right, actually the biology does tend to follow. But in that context, what we need to do is make sure that, well, a bit like any livestock on a farm, the underground livestock that's the soil biology has the right food to eat, the right environment to live in. So that's again about structure and the balance of air and water, but also the importance of a diversity of plants in space, hedges, intercrops, cover crops, but also in time through crop rotations. Healthy soils are characterised by an active, balanced ecosystem below ground. So not just bacteria and fungi, but the organisms that eat them, literally, that eat them up and that release nutrients. And that balanced interaction, that food web below ground is actually really important for delivering a whole range of soil functions, some of which support plant growth, so nutrient cycling, structure formation, and some of which are really important for climate regulation, so for sequestering carbon in our soils or for filtering water and improving its quality. One of the key things that affect soil biology is actually the plants growing on the surface. So one of the things that it's really important to do is to facilitate plant growth. The better plants grow, the more deeply into the soil their roots penetrate. And actually, the photosynthesis that happens above ground, the carbon that the plants trap through sunlight from the atmosphere, is powered through into the root system, and much of it actually leaks out. We call them root exudates, complex organic acids that are then decomposed and broken down by the organisms in the soil, and that become the fuel to keep things going, along with the roots themselves as they die and decompose, and the tops of the plants that might get incorporated through straw or other plant residues. These inputs of sunshine into the world, the dark world beneath our feet, power the system and enable that biological interaction to decompose the organic matter so it doesn't build up at the surface, but also then to power the rest of the system and support its function. All soil organisms need something to eat, just like we do. Without something to eat, they'll die, the population will become nearly nothing, the functions that plants need to grow will no longer be happening. The soil will be dead. And we can think of soils where that might have happened due to sterilisation or due to flooding, for example. And those need stimulating, and plants do that through their root systems and support and enable the soil organisms to grow and develop. And because the soil organisms can't, well, not many of them can generate their own energy, they're really dependent on the plants to bring the energy of the sun into the system. And it's that carbon, like the food that we get, full of carbon, full of nutrients, that enables those organisms to decompose, to digest, to get the nutrients they need to grow and develop. And it's those growing and developing functions that actually power, that enable all those interactions to happen and change and facilitate the things that we want, the ecosystem goods and services, plant growth, water filtration and so on. I think that a vibrant soil ecology will really support crop health as well as the health of the soil. And that can be directly through interactions around soil-borne disease and management of soil-borne diseases, like, for example, in potato crops, the reduction in the risk arising from potato cyst nematode, the loss of the cysts from the soil, or the competition between organisms that means the one that wants to come and eat the plant roots just can't get there because someone else gets in the way. And we see that with common scab in potatoes, that a more varied Streptomyces community can outcompete the one that's pathogenic, so we don't get the same risk with common scab. And so the community itself is a bit self-regulating. If the community itself is vibrant, what it can do is support the plant to grow well. It can help defend it against disease, but it can also supply the nutrients and enable the water uptake that's needed. And the association between plant roots and arbuscular mycorrhizal fungi, a sort of shared work, for example, there is really important, because those mycorrhizal fungi feed from the sugars coming from the tops of the plants into the roots, and the fungus ramifies out into the soil. It's like the plant gets loads of extra roots for free, potentially even kilometres worth of extra roots for free, that reach out into the soil and bring back the slow-moving nutrients in the soil like phosphorus or micronutrients, and also water.